Good morning, everybody. This is Pradeep Kumar, Senior Joint Commissioner, and I welcome you this session that is digitization and mapping of irrigation assets in QGIS. In this lecture, we will learn how we can create a vector data. In my past two lectures, you have learned about how we can add vector data and using that vector data, how we can create a map. And also, we have learned how to export that map into PDF format so that we can include in our reports. But how to create those vector data? In this lecture, we will see this method, and that method is called digitization process in any GIS software. Here in QGIS, there is a different set of tools available, and using that tool, we will learn how to create our vector data for a irrigation project. We will digitize the canals, structures, various headworks, and various point structures, that is aqueducts, etc. And we will create the vector data in the different layers. So let's start. I request you please open your QGIS software.
Okay, and then you first create a new project new, and then save the project, save in a new folder, create new folder. Okay, give project name, let's say Zurala irrigation project. Okay, and here project 1, or you digitization. Save it. Okay, so we will use this common folder to save our vector data also. And to start with this process, I have told you earlier in my first PPT about irrigation asset mapping, and also how we can identify different feature in satellite image. You required certain inputs. Very first is satellite image. You can procure that satellite image from NREC, and then if you get the image in subset, you merge it and then clip your area of interest using command area boundary. Okay, command area boundary can also be created using distance process. If you have command index map, you can georeference it, then load in the QGIS and trace the boundary of the command area, and you can create a vector data. The procedure of digitization you can learn in this session. Once you know how to create a vector data of different type like line feature, point feature, and polygon, then every type of layer, whether it is a command area boundary or whether it is a canal network point data like structure point data, you are able to create it. So I have given a data set to you, that is Jurula irrigation command area. The satellite image I have provided you in data folder. Okay, so first you have to load that data, that satellite image, on your canvas area. So for loading that raster data into canvas area, you have to use this tool, open data source manager. You click it, and because you are dealing with raster, so you have to click here raster. Okay, for if you want to open vector data, that is .shp, then you have to use vector. But if you are dealing with raster like .img, .png, .jpg, .tiff files, they are all raster files, so you have to load these files using this tab. Okay, so add raster layer, then browse to that folder which I have provided to you, that is QGIS and WXIS data. In that folder you will find this folder, PMGIS data Jurala. In that folder the satellite image is in this folder, Jurala satellite image, and this TIFF file, okay, around 1.7 GB. This file you have to load. Okay, select it, open it, add and close. Okay, so this is our satellite image, which you can see here that it actually merged image. You can see different contrast, 3 different contrast region. Okay, so these are 3 subsets which was merged, and that image was made in single, and then using boundary layer we clipped that image, and this is our now become a input data for creation of vector data. Okay, so first try to know or try to see different features in this particular image. Okay, you can also know the resolution of this image by going property, and in information you can see the pixel size around 2.6 minus 2.6, I mean it is 2.6 meter resolution image. Okay, so it's a Cartoset 1 image that was procured in 2008, but if in today you can procure Cartoset 2 image which is 1 meter resolution so you can easily visualize different features. You try to explore this image by using zoom. You can use this button zoom, or you can also use your mouse wheel to zoom and zoom out and try to see different features. Okay, now this particular image is looking dark, so you can use raster tool of QGIS to enhance the visibility. So how we can enable that raster tool? You click view, go to the toolbar, and then you enable this raster toolbar. Okay, enable it. This is the raster toolbar. Okay, so if you want to see the thing or feature in clearly, means you want to enhance the contrast, you can use this tool, local cumulative cut stretch. You click it and you see that now you can easily see the canals. Okay, so using this tool you can enhance the visibility of your raster image, and after that you can see different features and structure clearly in your QGIS canvas. Okay, so this is using pan tool, you can pan the image. Okay, now this become more white, so you can again use this tool. So locally you can enhance the image. So this tool is for local enhancement of the local, means the area you see in a canvas area. But if you want to enhance the visibility of whole image, or you want to go is original setting, then you can use this. So this one, local histogram stretch, or this one. Okay, so this again now become the original setting of contrast. You want to see full, you go there again, click it again this. So you can see this is our Jorala reservoir, and this is your Jorala dam come reservoir, and this is your left bank canal, and this is your right bank canal. Okay, this is your head regulator. Okay, and you can see this is a, I have told you in my PPT that this must be a aqueduct. Okay, so try to see different features. Main task of digitization is to identify different features in your satellite image using some basic interpretation technique that I have told you in my PPT. Now so in this session we will create, very first is vector data for canal network. Canal network is a line feature, so we should use line type of vector layer. Then we will digitize this reservoir. It is actually a area, so you should use polygon type of vector layer. And the structures, we will use point data, so we use point layer, point vector layer. So first we will start with our canal network. So always start from the main head regulator. If you have canal line diagram which have different RD values, you can same value or length can also be measured in this canvas area. For measuring the length you can use this tool, measure line. You click it, okay, and if you measure, so you can know. So this distribution started from around 1.1 kilometer, and you will see this RD value approximately same in your canal line diagram also. So you can make out that this is actually a canal which is starting from RD value 1.12. So like this way you can make out whether it is a canal or a road if you have a canal line diagram. It helps to identify the canals. Also you can use that map to name this particular canal, whether it is a distributary or a branch canal. Okay, so that naming I think provided in the canal line diagram, same naming you can use while creating your vector data. So this is how you can calculate the length. Okay, close it. Now we will start our digitization process. I have mentioned in my first PPT, that is Introduction to GIS, the basic principle behind is that you have a base map satellite image. If you put a transparent sheet on that particular map and start tracing the feature using a pencil, you will get the information in your transparent sheet. Similarly, in any GIS software, you have to create a first empty save file. Okay, that empty save file, then using this tool, that is editing tool, pencil tool, you can trace the feature and store the that spatial information in empty save file. That is how the data is created. Okay, so first we should create a empty save file of line type So for creating a vector data, you have to use this new save file layer. Okay, click here. A new dialog will come. So you have to give three inputs, that is file name, then geometry type, and your CRS system. So click here, then open the folder which we have created, that is Jurala irrigation project, and name it canal network. Okay, then because it is a line type feature, change to line. And third is you have to give reference system CRS system. Make sure CRS system should be same as of your raster data. So raster data CRS is EPSG 3857. So you have to assign the same CRS 3857. If you are not able to see this CRS in this list, then you can write it here 3857 and corresponding CRS will come here. You select it, press OK, don't change other thing. Then you have to create your attribute field. What are the information you want to store about this feature? First is name. Okay, so you create a field name. Here in this field we will store the name of each canal. You add to this field once you have created, give it is text data, length is 80, add to this field list. So one field list you can see, first is ID, that is default. Second field name is come. Okay, then you can also give another field like length. It should be decimal number, length 20, add to the field. Okay, fourth field you can also give like status, whether it is complete or not, status. Okay, you can add this field. Similarly, many fields can be added, but it depends on what type of analysis or study you are doing. Accordingly you have to specify the fields. Okay, some fields are entered while digitization process, some fields are calculated later on. You can also add the column or field after you have created the layer. So once again I repeat the procedure. You have to create empty save file using this tool. Once you click this new dialog box will come. Then you have to give the name, geometry type. If it is line feature, you have to specify line. If it is a polygon, you have to specify polygon. If it is a point feature, you have to specify here point. Okay, third is your CRS. The CRS must be same as of your raster data base layer you are using. And then you can add fields, that is attribute fields, the type of information or property you want to store while digitization process. Once this is done, then you can click OK. One more thing, if you have, suppose you have entered this length wrongly, so you can remove that field also. Here you can see remove field, again enter length. It's a text. Text means type of data you want to store in this field. If you want to store name, it should be text. If you want to store any decimal number like length, you can place decimal number. And length is, it's your capacity, means if you give 80, means your text number of letters in a particular string can up to 80. And then you have to click this add to field list. Okay, so press OK, and then you can see a new layer has come in your layer panel. Okay, Now this is an empty shape file and this is your base layer. You have to start from the head regulator. Always start from the head regulator, and then you want to store or you want to trace this layer, corresponding layer we have to create it. So first you highlight that layer, then use this tool, toggle editing. Okay, first you have to highlight this layer, then toggle editing. You will see this layer, a pencil mark will come which shows that this layer is right now in edit mode. Then you have to use this tool, this add line feature. This is the tool to adding the data in your layer. So click it, you will see your appearance of mouse cursor become cross like this. Okay, so now you can start tracing your canal by clicking the points, not just trace your mouse. You have to click the points like this. Okay, you have to click, make sure at the sharp turn you have to click more points. Okay, now we have reached at the edge of your canvas area. So how we can pan the image without disturbing the digitization process? So please listen carefully. First you have to press your spacebar. You have to keep press your spacebar. You can see your mouse cursor become now this hand. Okay, and then move your mouse. Don't release spacebar, and then you can release the spacebar and start tracing. Again, keep press your spacebar, move the mouse, start tracing. Press spacebar, release spacebar, start tracing. I am doing fast, so but if you are doing actual work, you have to carefully trace the line. Then again, press spacebar, move your mouse, and start tracing. You can see now here you can see there is some misalignment with the canal. This may be due to merging of different data set. So maybe your georeferencing was not done properly. Okay, so some misalignment has come, but you can take a middle point. If this type of mismatch is there in raster image, you can take a middle and then start tracing. Okay, you can now if you want to stop that tracing, you just right click it, give ID and name. It is a right main canal. Status, anything you want to give, complete or incomplete or repairing, you can specify here. Length we will measure later, so just give these two name, two entry, ID1 and name. Press OK, and you can change the appearance also. Just click it. Okay, Now if you pan your image, you can see this much of canal we have digitized. You change that. Okay, still your data is digitized but it's not saved, so you have to click the layer and again you have to click this pencil tool, save it. Then that particular feature up to this length is saved in your vector layer. Okay, that is how we can create your vector data of a line type. You can change the color, change the thickness. Okay, now next we will digitize a distributary of this right back canal. We will start our digitization process for first distributary, that is this one. You can see clearly here. Okay, so problem comes here, how you can actually connect to this main line while digitization process. If you start digitizing by normal method like this and then add feature and try to digitize this canal in a normal way, name D1. Now by seeing it, anybody can say that it is properly connected, but if you zoom it, you will see it is not connected, or maybe you will see some overshoot. So how to start digitization so that this particular branch should connect this particular main feature? So you have to use here the snapping option. The snapping tool help you to snap the near features, like if you want to snap the endpoints or a line segment or a vertex of another feature, then you can use snap tool. So how to enable snapping? So before that I will delete this digitized distributary. So how you can delete? You click this layer, then select this and delete. Press delete in your keyboard. Okay, then go view. You have to click view, toolbar, and enable this snapping toolbar. Okay, this snapping toolbar will come here. You can change this. Okay, so now we can use this tool. So to enable snapping, you have to click this magnet. Okay, now snapping is enabled for this layer. Then you have to give snapping radius. Snapping radius nothing but you want to define the area around a particular feature, that if your mouse is within the 20-meter radius of that particular feature, it will snap the point or a segment or a vertex. Okay, so you can change the snapping area using this value. Then you have to use this all layer, whether you want to snap for particular layers, active layers, or all layers, you can change that option. Then you have to specify whether you want to snap vertex or segment or both vertex and segment. You can specify here. Okay, So we will use this tool and press this and then again toggle editing and use add feature. Now if you see, if your mouse cursor come within the snapping area radius, you will see a cross. Okay, this is a segment, this is your text and this is a segment. Now you can start digitization process of your distributing. So click, once you click in a snapping area, the point will be selected on the cross. So click here, then start digitization of your first distributary canal. So that is how you can start from the right place and join to your main feature. I am digitizing fast, but you have to do carefully. So I stop here, digitization of canal network. So I am giving ID 2, name distributary 1 number. Okay, press OK, and you can see, if you try to zoom this point, you will see it is connected properly. Okay, so using snap tool you can actually join at a right place. Now suppose you want to continue this layer. Sometime what happen, if your feature is very long, then you have to stop this digitizer in between, and if you want to restart again, then this snap tool also help at that time also. So you can snap the endpoint accurately using snap tool. Okay, start digitization. You can see you can snap the endpoint correctly. So click here and then start digitization again. Now suppose you click outside or not on the canal feature, you want to undo your editing, so you have to click or press the delete button in your keyboard. You delete, press delete again, and you can undo your digitization process. Then start again. Once again, suppose I click outside, press delete and then start again. Okay, suppose you have click outside this, press again and then. So I will stop here, right click it, okay, give ID 1, right bank canal, okay, and you can see I have now. If you select that feature, you can see this is the part we have digitized earlier and this is the later part, but right now it is not connected. So how we can make the connection is okay, but how to make the feature of same ID? You can use merge tool. So for merging you have to enable your advanced digitization method. So click view toolbar and click here advanced digitization toolbar. This is the toolbar for your advanced digitization method. I want to join these two segment. So this is the tool we have to use. So first you have to select your earlier segment and then press Ctrl, then select second one. Once these two segments, you, you will see yellow color. Selection means the selection color is yellow. So these two segments are now selected. Click this merge selected feature. Okay, it will ask which feature you want to keep your ID and attribute. So this one is your first one. So I want to keep this attribute. Take attribute from the selected feature and press OK. Now it become a single entity. See, so that is how you can continue your work. Next feature I will digitize. So you can save it again. You save it, press by clicking the pencil tool. You save that feature. Okay, and so this is become your first vector data, that is canal network. Okay, so I hope you understood the procedure. Okay, different canals and different you can identify in this using remote sensing interpretation technique, or if you have a canal tree network or canal line diagram, by using this measurement tool or an RD value of that canal line diagram, you can make out the network also from using that field data. Now we will create second layer, that is polygon vector type data for this reservoir. The procedure is same. First you have to create empty save file, give the name reservoirs. Now it is a polygon type, and third option you have to give your CRS of the raster data. You have to specify this, and you have to add field like name of the reservoir, add to the field, area, it should be decimal, add to the list. Okay, so right now only I will give two field name. You can later on add also. So first, okay, so then you can press OK. So new layer is created. So now I will digitize this reservoir. So first you click this layer, then use this toggle editing and add this feature. Okay, zoom to that starting point from where you want to start digitization. Okay, and start tracing the boundary of your reservoir. Press spacebar, move your mouse, release spacebar, start digitization. I am doing very fast, but if you are doing actual work, you have to trace very carefully. Suppose I have clicked outside of that boundary, so press delete and again delete and start again. when you do actual work, please you have to trace very carefully. Now digitization is actually very cumbersome procedure, because 80% of a GIS specialist work is only in digitization process, and this is very basic operation to create your data. There is another way to extract the water bodies, but for that you have to use multispectral image, and using image processing software, by using different bands you can automatically extract the water bodies area. But in this, because we are using panochromatic image, we have to use this method only, that is digitization process, to create the boundary of the reservoir or any water bodies. I am doing very fast just to show the procedure how we can make your vector polygon layer. Okay, so once you reach at starting point, just right click it, give id 1, name Zurala reservoir. Okay, area that will be calculated later on, and press OK. So this is your first feature of polygon type in your polygon layer, that is reservoir. Still this is not saved, you have to click this pencil tool, then save it. Okay, and you want to see its attribute table, you click here and you click here. Okay, you will see first feature is added in your reservoir layer. Now suppose you want to add another feature, again you have to click it, add feature. Okay, zoom to the second water bodies like this and start digitization. To name, so we can give name. Okay, I am giving ABC, just any name, but you have to give proper name. Okay, so second feature you can save it, and you can check its attribute table that second feature is also added. So like this way you can add. Okay, you can add this reservoir also. Like this you can digitize the polygon feature. So next task is to create our point type of vector layer. We will create this layer for irrigation structures and other civil structures like road, bridge, railway bridge, or other bridge or other type of structures. For that we have to create a empty point type of layer. So the procedure is same, you have to create this empty shape file, assign the name structures, now geometry type is point, and assign CRS, that is 3857 and field name. Now here, because in a particular irrigation command area there may be so many type of structures, and if you assign name for every structures, then digitization process may become cumbersome or lengthy. So what you can do, you specify the code for each structures. For example, you give one for aqueduct, you can give two for other cross drainage structures, three for regulator, road bridge for four, and like that you can make a code. And once you have completed your digitization process, then you can change the attribute tables in one go by changing that code into a name. That can be done. Okay, so the design process become easy like this. So here I am using one for aqueduct, the code one for one aqueduct, two for other cross drainage structure, three for regulator, four for road bridge, five for other bridges, six for other structures. Like this I am going to digitize my point type of structures or point data layer. Okay, so I am giving here struct code as a name. Okay, code may be integer, so you can specify integer, add to the list. Another, you can fill the status, whether it is complete, incomplete, proposed. You can give any status. Okay, okay, any type of field. If you want that this particular field should be mentioned in that attribute data, you can create. So press OK, then click this toggle editing and add point feature. Okay, your mouse cursor become this type of appearance, and now locate the structures. Start from the main head regulator. Very first structure is a, you can see it's a road bridge. You click it, ID 1, structure code is 4. Okay, and then go forward. It is a regulator, ID 2, struct code is 3. Now it's aqueduct, ID 3, struct code is 1. So like this you can add points. Now it's a canal, so it must be a regulator here. Okay, click here, ID 4, struct code is road bridge 4 is 4. Okay, now it's a road bridge. Click here, ID 5, struct code is 4. Okay, now it's a canal, you can see it's a canal. So here ID 6, struct code is regulator 3. It's a bridge, road bridge, ID 7, struct code is 4. Now it's a canal, so it must be a regulator here. Click here, 8 ID, struct code is 3. Another canal, ID 9, struct code is 3. Another canal, ID 10, struct code is 3. Now you can see a stream or a drainage is there, cross drainage is there in this channel, but type of structure is not, it's not a aqueduct, so we can say it is a other cross drainage structures. You click this point, id 11, start code 2. Here also you can see this is id 12, struct code is 2. So like this you have to identify structures and then assign the points and give proper attributes. Like this way you can map your irrigation assets. Okay, so I am stopping here because the procedure, basic procedure or principle is behind this. I have explained in this lecture. So just save it. Okay, later on you can change this struct code into name. Okay, I will tell you in my next class how you can, by typing certain code in your SQL editor, you can change the struct code into a name. Okay, so I hope you understood how we can digitize different type of features like line type or area type like water bodies. If you have a command area index map, also you can georeference it and you can trace the boundary and you create a command area boundary layer like the way we have created for our reservoir. Same methodology will be used. So I hope that by this video you understood the step procedure involved in digitization of point type of features, line type of features, and area type of features, or polygon type of features. Next, suppose you want to modify or you want to correct the data, how we can do. For example, if you see this canal is, this digitization of this canal is not proper, so how we can modify this feature? So first click it, put into in edit mode, then using this tool, vertex tool, you can actually change the vertices like this. You can change the vertices. Okay, now if you see, we can only change by shifting that vertex point. Okay, now here we have only 3 vertex. You can also add vertices by like that. Double click it, you will see one vertex is added. Again double click it, like this you can increase the vertex. You have to double click it. Okay, okay, now if you want to delete particular vertex, you click here, press delete, you can delete the vertex. You want to add vertex, you click here, double click it. Okay, so like this way you can increase the vertex points, because the vertex point is only, you can say, gripping point by which you can change the features. So more vertex points, more smooth geometry will be generated in your vector data. So by shifting this vertex point, you can align your feature more accurately. Like this way you can modify your geometry, or okay, we will take another example for reservoir. Suppose you want to change this area. How we can? Editing for canal network. You click here, save that, and now we will start for reservoir. Again click pencil, then this vertex tool. Okay, go there. So you want to increase the size, so you have to add more vertex point. You can see, double click, you are adding vertex points. And then we can change the boundary like this. Okay, for shifting just click once. Please remember, for shifting you have to click once, and if you double click, a new point will be added. Like this way you can also change the boundary of your polygon layer also. Once you have done, you click this pencil again, save it. So that is how you can modify or rectify your errors. Okay, so I will stop this session here. I hope you understood the procedure of digitization for three types, like line features, point features, and polygon features, and how we can modify the boundaries or modify the features. Thank you.